Good morning. Today we are starting about the total internal surface. First, to consider about this, let us consider the diagram of the total internal surface. Now let us consider the diagram. Now A, P, Q, R are the some points on the rays of the light. Now let us consider OP is there. Next here we are considering the I is less than C. I means what? It is the angle of incidence lesser than the critical angle. Again here we are considering I is equal to C. I means angle of incidence which is always equal to the critical angle. And again here also we are considering I is greater than C. I means what? The angle of the incidence which is greater than the critical angle. Now let us consider the OP, the ray which is passing from OP. Okay, it is get reflected towards the or away from the normal. It is away from the normal. This away from the normal we are calling as the ray which is made to pass from the denser medium to the rarer medium. When it is passing from the denser medium to the rarer medium, it always gets away from the normal point. Now from this we have told that I is less than C. Here we are considering the angle of the incidence is very less than the critical angle. When we are getting I is very less than C, when the ray of the light which is made to pass from the denser medium to the rarer medium which is get away from the normal, then we are telling that I is very much less than the C. Next we are considering again one more ray of the light. Now OQ. Okay, this OQ. Here see the ray which is made to pass from the denser medium, it does not go to the rarer medium. It will be up to the denser medium. When we are passing the ray of the light from the denser medium to the rarer medium, the ray of light which is not getting reflected to the rarer medium, that time we are getting R is equal to C. We are getting I is equal to C. When we are getting I is equal to C, when the denser medium or the ray of the light which is made to pass from the denser medium to the rarer medium, it is not go to the rarer medium. It does not get reflected. That time we are getting the equation as I is equal to C. Here it will get the separation of the normal of the surface. Here it will be the separation of the surface from the OQ ray. Next last one is your OR. Next point is your OR. Now let us consider OR, the ray of the light which is made to pass from the denser medium to the rarer medium. Okay, when we are passing from the denser medium to the rarer medium, the ray which is passing OR, it does not get reflected back to your rarer medium. If it does not get back reflected to the rarer medium, then we are calling it as what? We are calling it as the critical angle which does not get the reflected back. Now let us consider here we are considering the I is greater than C. Here we are telling that angle of the incidence is always greater than the critical angle. And here we are considering in the first case I is less than C we are considering. Next we are considering I is equal to C. Here first point we can tell that OP ray it is going from the denser medium to the rarer medium gets back towards the normal point. And in the second ray OQ it does not go to the rarer medium. It will be in the denser medium and it gets the separation of the surface to the normal point. Next OR, it will go from the denser medium but it does not reach the rarer medium. It gets reflected back to the surface. If it gets back reflected to the surface, then we are calling it as what? Critical angle. Now next we are studying the critical angle. Just here we have to define the critical angle. According to the critical angle, just we are considering a ray which is made to pass from the denser medium to the rarer medium. Consider it is passing from the denser medium to the rarer medium. When it is made to pass from the denser medium to the rarer medium, we are considering the angle of incidence should be at 90 degrees. The angle of the incidence it should be at 90 degree. That means we are calling it as what? Critical angle. Critical angle means what? When a ray which is made to pass from the denser medium to the rarer medium which is get reflected towards the angle of incidence I is equal to 90 degrees, then we can call it as what? Critical angle. Next here in the same way we have to study about the total internal surface. The definition of the total internal reflection made to pass from the denser medium to the rarer medium. When we are considering the ray which is made to pass from the denser medium to the rarer medium, here the denser medium, the ray of the light which is made to pass to the denser medium gets reflected back towards the denser medium. It gets reflected back towards the denser medium. That time the angle of the incidence is greater than the angle of incidence is always greater than the critical angle. If the angle of incidence is greater than the critical angle, then we can call it as what? Total internal reflection. In the critical angle, just we are considering it should be at the 90 degree. When a ray of light which is made to pass from the denser medium to the rarer medium, that time we are getting the angle of incidence I should be 90 degree. Here we are considering when the ray of the light which is made to pass from the denser medium to the rarer medium, it does not go to the rarer medium but it gets reflected back towards the denser medium, then we can call it as what? Total internal reflection. Now next we have to study about the relation between the critical angle and the refractive index. This refractive index can be denoted as what? Small n, I, small n, and the critical angle we are telling it as C. Here we are telling that refractive index can be denoted as small n. Okay. Now let us consider the diagram for your. Now let us consider a ray of the light which is made to pass from the denser medium to the rarer medium. What will happen? And here we have to find the relation between your critical angle and the refractive index. Now let us consider one is your rarer medium, other one is your denser medium. Here we are considering I1 is equal to C. I1 means what? It is the refractive index is equal to C, and I2 is equal to, we are considering 90 degree. Now according to this we know that equation N1 sin I1 is equal to N2 sin I2. Just we are considering the equation as N1 sin I1 is equal to N2 sin I2. Now we know the value of I1 and I2. In the case here we are considering in your diagram I1 is equal to C, that is your critical angle. Then I2 is equal to, it is at 90 degree. Now let us consider these two equations and put in this equation 1. Put the values of I1 and I2 in equation 1. In equation 1. Next we are getting the equation as N1 sin I1 means C is there is equal to N2 sin I2 means 90 degree. We know that sin 90 degree is equal to 1. Sin 90 degree is equal to 1. Put this in equation. N1 sin C is equal to N2 sin 90 degree means what? Is equal to 1. Therefore, sin C is equal to N2 by N1. Or this can be also written in the form of C is equal to sin inverse N2 by N1. C means what? It is the critical angle. N1 and N2 are the two refractive index. In this case, again we are considering N2 is equal to 1 and N1 is equal to, we are considering it as the N. We are considering in the air or the vacuum case, we are considering N2 is equal to 1 and N1 is equal to N. Let us consider this equation as 2. Put N2 and N1 in the equation 2. What we are getting here? Equation C is equal to sin inverse N2 by N1 means 1 upon N. C is equal to, we are getting the equation as sin inverse 1 upon N. Therefore, from this we can tell that the higher the refractive index of the medium is the smaller than the critical angle. The higher the refractive index should be the smaller than the critical angle. This is the relation for your critical angle and the refractive index. Let us consider first equation. What we are considering here, N1 sin I1 is equal to N2 sin I2. We know the values of I1 and I2 according to your diagram. Just we are putting the value I1 is equal to C, I2 is equal to 90 degree. Next we are substituting N1 sin C is equal to N2 sin 90 degree. Sin 90 degree is equal to, we know know the equation, it should be 1. Next, n1 sin c is equal to n2 into 1. Therefore, we are getting sin c is equal to n2 by n1. Just we have to find the value of this c. C is equal to what we are considering, sin inverse n2 by n1. Now let us consider in the air or vacuum we are considering n2 is equal to 1, n1 is equal to n. n2 and n1 are the refractive index. Therefore, c is equal to sin inverse of 1 by n. C means what? It is the critical angle. C means it is the critical angle. And n1 and n2 are the two refractive indexes. This is the relation between the critical angle and the refractive index. Now next we are studying the condition for the total internal reflection. Condition for total internal reflection. Now just we have studied here, when a ray of the light which is made to pass from the denser medium to the rarer medium. By using that only we have to do the first one. See here, when a ray of the light which is made to pass from the denser medium to the rarer medium, it is the condition for your total internal reflection. This we are considering as the first condition. First condition means what? When a ray of the light which is made to pass from the denser medium to the rarer medium. Now next, second one. Now just we have considered the equation. We have told that I is greater than C. Here the angle of the incidence, I is greater than the critical angle. Is always greater than the critical angle. These are the some conditions for the total internal reflection. Now next we have to study the application for the total internal reflection. This total internal reflection we are using in the brilliance of diamond. It is used in brilliance of diamond. It is also used in the optics. It is also used in the optics. It is also used in the mirage. These are the some applications which is used for the total internal reflection.